This question talks about a chain of 3 boxcars, each with some mass. We don't know what that mass is, but they're identical. We'll call it mass equals 1 boxcar. They come along and they smack another boxcar. The conservation of momentum says momentum doesn't change. And if momentum doesn't change, that means the momentum before is the same as the momentum after. The momentum before, the definition of momentum is mass times velocity with some sense of direction. So we could identify these as vectors. But in this case, we know we're going from left to right. And the momentum before is mass times velocity. The mass in motion here is 3 boxcars. And the velocity is given in the question. And we know after they hit this boxcar, there's going to be 4 of them in motion. And momentum, this has 0 momentum, so the momentum before was completely held in these 3 boxcars. After the collision, they're all going to be moving, and the momentum is going to be carried off by all of them. And there's going to be, so the mass of all of them together is going to be 4 boxcars with some unknown velocity. The momentum before you know, the momentum after you don't, but you can solve that because these 2 momentums are equal. And notice there's m and unknown m in each of them, and they're going to cancel. Kinetic energy is not conserved. Total energy is conserved, but energy has many different categories, and any one particular category of energy is not required to be conserved in most circumstances. So while total energy is conserved, there's no conservation law just for kinetic energy. Kinetic energy equals 1/2 mv squared. We know we have 3 boxcars here. We know the velocity they're moving at, and we can compare that to the final velocity, the kinetic energy before, kinetic energy after, and we know that here this mass is going to be 3 boxcars, this mass is going to be 4 boxcars, and this is the velocity before, which we know. We can figure out the velocity after, which we know, and then we can compare these 2 values of kinetic energy and see how much kinetic energy was lost. Usually in inelastic collisions, kinetic energy is lost.